Hello everyone. So today we'll learn heights and distance with the class 10 topic of ICSE based on the concept of the trigonometric ratio. So using the trigonometric ratios concept, we'll see that how we are going to deal with problems which is related to heights and distance. So first, we have to understand two particular terms here, and everywhere these two terms are going to be a very crucial factor. So we have to first understand the scenario and accordingly we have to apply the concept. So the two terms that we all need to know is, one is called the angle of elevation and the second one is called the angle of depression. Okay, so we have to first clearly understand that what these two things actually mean. Now suppose, let me give you all an example.
Okay, so I'm Michael Dutta. You're watching GANITMATICS. How har sawal hoga solve. Okay, those who are new to this channel, you subscribe to the channel so that you don't miss out on any new videos.
Now suppose this is a ground. Suppose this is the ground level. Okay, and let me consider that this is a building. Okay, so let me name this. Say, for example, AB is a building. And suppose a person is standing somewhere here. Okay, let me name that point as X. Now, if I consider that a person who is standing at the point at the location X is watching the top of the building. So in that case, obviously, that person is going to see the top of the building in this way, right? So that means along this line, that person is going to see the top of the building. So this line along which a particular person is watching the top of the building, this line is called the line of sight, right? Now the angle that this line of sight is making with the horizontal. So horizontal is always based on the location from where we are watching a particular thing. So that means according to the point X, our horizontal is XP, right? So the angle between the line of sight and the horizontal, which is this, is the angle of elevation. So that means angle of elevation concept is only coming into the picture when we are watching something which is on the top. So that means when we are elevating up, when we are watching in the way that it's elevating, okay, up. So then it's angle of elevation, right? Now this is the concept of angle of elevation. So in the same way, we have another scenario where the situation is something like this. Like for example, if I consider that, say, this is my ground level, okay, and suppose this is a building or tower, anything. Let me name it as MN, and suppose there is a object on the ground level, say Y. Now let us consider that a person is standing on the top of the tower and that person is watching that object which is at the ground. Then obviously the person is going to watch in this way along this line, isn't it? Downwards. That person will look downwards in this direction. Okay. But the point here is, since the person is standing on the top, so for that point, the horizontal is going to be this line. This is going to be the horizontal. So if I again apply the same concept, the angle between the line of sight, which is this is the line of sight, and the horizontal, so this angle is the angle of depression. But why this scenario is the angle of depression, this angle? Because in this case, we are looking down. That's why it's the angle of depression. So it's the angle always between the line of sight and the horizontal at that point. Okay. But when we are solving, we can also apply the concept of alternate angle. So that means whatever angle of depression that we'll get here, it will be same as this angle, applying the concept of alternate interior angles. Okay, so these are the two concepts that we all are going to use in this chapter, right? And using these two concepts, we are going to solve the problems. So now we'll see few problems from the concise, both the exercises 22A and 22B, so that it becomes clear. And if any question comes from this particular portion, you all will be able to attempt it. And definitely there is a sure shot question of 4 marks, 22A. So in the concise page, according to the new edition, should be 336. Let's see question number 4. It says, two persons are standing on the opposite side of a tower. So let's draw it in this way. So let's say this is our ground level, and let's say this is our tower, which we can name as AB. Now, since they have told that the two persons are standing on the opposite sides of the tower, so let me consider one person is on this side, X. Let me name the position of that person as X. And one on the other side, let me name that location of that person as Y. They observe the angle of elevation of the top of the tower to be 30 degree and 38 degree. So that means the angle of elevation of the top for one of these person is 30 degrees. So that means this is 30 and the other one is 38. So the one which is closer seems to be bigger. So that let's take that as 38 and let's take this as 30. And the question is, find the distance between them if the height of the tower is 50 meters. Okay. So that means basically we need to find the XY length, right? So now let us first concentrate on any one of these particular triangles. So obviously if it's a tower, it's going to make a 90 degree because any vertical thing standing on the ground should be at 90 degree with the ground. So that means here in triangle AXB, now since the height is given and my concern is to get XB, so that means I'm going to relate this and this. Now for this triangle AXB, since the given angle which is 38 degrees this angle, so the angle which is opposite to that, if I treat that as a perpendicular, and that side which is adjacent to that at the base, that means we have to use that ratio which involves perpendicular and base. That means the tangent. So that means tan of 38 degree is equal to 50 by XB, right? Now what we want to find is the value of XB. So XB will be 50 divided by tan 38 degree. Now tan 38 degree, we have to take it from the table. Tan 38 degree from the table, we are getting as 0.7813. And then if we divide 50 by 0.7813, it will be approximately so it's coming near to approximately 64 meters. Okay, now let's move on to the other triangle. So in triangle ABY, similarly, if I apply the same concept, then tan 30 degree will be 50 by BY. Now tan 30 is 1 by root 3. So that will be equal to 50 divided by BY. So BY is going to be 50 root 3. Now we all can substitute the value of root 3. And then in that case, we all will get the answer. So the answer will be approximately 86.6 meters. So that means since we need to find the value XY, so therefore it's very clear from the figure that XY is nothing but is the sum of XB and BY. So we have both the values. So we'll just simply add. So we'll get the final answer as approximately 150.6 meters. So that is how we can deal with such questions. I hope this question is pretty clear. Now let's move on to another question. Question number 9. It says at a particular time when the sun's altitude is 30 degrees, the length of the shadow of a vertical tower is 45 meters. Okay. So basically that means if this is my ground level, and let me consider that this is the tower. Let me name it as AB. So let me consider that its shadow is BC. Now this shadow BC is 45 meters. And since the sun's altitude is 30 degrees, so let me consider that this is my sun. So altitude basically means they mean the angle of elevation from any point. So this is our 30 degree. Now there are two parts in this. So the first part, they're asking that find the height of the tower. Okay. So here also, if this is my required, if this is the given angle, then in that case, AB is becoming the, we can treat that as a perpendicular, and the adjacent side BC we can treat as the base. So perpendicular and base, that means we are going to apply the ratio of tangent. So that means in triangle ABC, tan 30 degree will be AB by 45. Okay, so now tan 30, as we all know, is 1 by root 3. So that basically means AB is going to be 45 divided by root 3. We can rationalize here. So it'll be 45 into 1.732 divided by 3. 3 will cancel 45 15 times. So 15 into 1.732. That's coming as 25.98 meters. Now in the second part, they've told us that find the length of the shadow of the same tower when the sun's altitude is 45 and 60. So now if we know that the height is 25.98 meters, then in that case, in this triangle again, tan 30, so the first case 45, so tan 45 degree will become then 25.98 divided by BC. Now tan 45 is 1, so that means if I cross multiply, BC will be the same value, 25.98 meters. And the second case, that is for 60 degrees, so tan 60 degree is going to be 25.98 divided by BC, which means BC is going to be 25.98 divided by tan 60 is root 3. We can again rationalize. So it'll become 3 in the denominator, and 3 will cancel 25.98 will go 8 times 24, then 6 times 18, and again 6 times 18. So 8.66 into 1.732, we all need to check. So 8.66 into 1.732, it'll be something near to 14.99, which can be approximately taken as 15 meters. So that will be the answer of the last part. Question number 12. So it says that a man stands 9 meters away from a flagpole. Okay, so flagpole, we all know, we all have seen flagpoles. So let me consider this is the ground level, and let me consider this is the flagpole. Okay, so the flag will be somewhere here. Now, suppose the man is somewhere here. The distance from the pole is 9 meters. Now, if I consider that the man is here, so his or her eyes will be somewhere here. Now, the angle of elevation of the top of the tower. So this is the top. And so for that, I will also need the horizontal here. So this angle of elevation is given to us as 28 degree. Now they have also told that the angle of depression of the bottom of the pool is 13 degree. So which basically means this angle is 13 degree. Okay. Now the question is to calculate the height of the pole. No problem. Let me name the flagpole as AB and this point as C. Okay, and this point as D. So let us deal one by one. Now, if this B, let me name this point as ICSE. So if B is 9, then obviously DC will be also 9. Okay, so we'll write it here that DC is equal to BE equal to 9 meters. Now, so in triangle ADC, so we'll again apply the concept. So this side is opposite to the required angle, not the required angle, like the given angle. So that we'll treat as the perpendicular. This we'll treat as the base. So that means tan 28 degree is going to be AD by DC, which is 9. So in that case, AD is going to be 9 tan 28 degree, right? Similarly, in triangle DBC, in the same way, tan 13 degree will be equal to dB by DC, which is 9. So that means dB is going to be 9 into tan 13 degree. Okay, so let us check the values of tan 28 and tan 13 from the table, and let's get these two values. Okay, so now if we see the table, then for the first one, that is tan 28 degree is 0.5317, and in that case this value, if we all multiply with 9, then this will become approximately 4.79, and here tan 13 degree is 0.2309. you all can check the table. So if I multiply that with 9, then we are getting 2.08. So that means now it's see from the figure, all of you, I need the entire pole, so which is AB. So it's clearly from the figure, it's AD plus DP. So we'll just substitute the values. So it's going to be 4.79 plus 2.08. So it's going to be approximately 9 plus 8. So one carry, it will be 4.87 meters approximately. So this is how we are going to deal with this question. So I guess now after doing all of these questions, sorry, this will be 6.87. Yeah, 6.87 meters. Sorry, we have added 4.79 plus 2.08, so it should be 6.87. So this is how we are going to deal with this type of questions. And after seeing these three questions, I hope you all are now confident and clear that how, using the concept of angle of elevation and depression, we can solve this type of questions. Now, next, we all will move on to the second exercise of concise, that is exercise 22B. Yes, so the first question that we'll see here is question number 4. It says that from the top of a lighthouse, which is 100-meter high. So let us consider that this is the ground level. And let us take this as the lighthouse. Let me name it as AB. And the height is given as 100 meters. Now they have told that the angle of depression of two ships are observed as 48 and 36 degree respectively. Find the distance between the two ships in the nearest meter, but there are two cases here. Once when the ships are on the same side. So let me first consider that the ships are on the same side. So suppose this is the first one, this is the second one. So that means the angle of depression, which are going to be, as they have given, is going to be 48 and 36. So obviously this one is 48 and this one is 36. So according to the alternate angle concept, this is 48 and this is 36 degree. So we need to find the distance between the two ships, right? So first of all, in triangle ABX, so tan 48 degree is going to be AB by BX. That basically means BX is going to be 100 divided by tan 48 degrees. And in triangle ABY, tan 36 degree will be going to equal to AB divided by BY, which means BY is equal to 100 divided by tan 36. Now, as it's pretty clear from the figure that the distance in the two ships is XY, which we can also write as BY minus BX. So that will be 100 by tan 36 degree minus 100 divided by tan 48 degree. So we'll take 100 common. So we'll be getting 1 by tan 36 degree minus 1 by tan 48 degree. Again, these are non-standard angles, so we have to take the values from the table. So tan 36 degree is 0.7265, and that for 48 degree is 1.1106. Now, if we calculate this, then approximately 1 by 0.7265 will be 1.38, and similarly 1 divided by 1.1106 is going to be 0.90. So in that case, it will be 100 into 0.48. So it will be approximately 48 meters. So the distance between the two ships, if they are on the same side, is going to be 48 meters. Okay. Now, the second case is different. The second case is basically when the ships are on the either sides, on the opposite sides, right? So in that case, let me consider that this Y ship is on this side, right? So let me denote it or represent it as Y dash, or let's say it's Y only, so that we can use the same information that we have. So BX and BY, these values definitely are not going to change. The only change will be, now if this is my X and if this is my Y, then the distance between the ships is going to be sum of these two distances, right? So in that case, then according to our concept here, it's going to be now 100 into 1.38 plus 0.90. So then it will become 2.28, and that's multiplied with 100 is going to be 228 meters. So if they are on the opposite side, then the distance between the ships will be 228 meters. So that is how we all can do this type of sums. So I think now after seeing these type of sums, now you all are confident and you all know how to do the questions related to heights and distance. Okay, so that much for this video. So for getting such videos on the similar topics or other topics, keep watching. And you all are watching Ganitmatics. I'm Michael Dutta. Ab har sawal hoga solved.